Right, so in this video we're going to look at the confidence interval for the proportion. In the previous video we looked at the confidence interval for the mean, so we were taking a sample of the population and we looked at the mean of that sample, and from that we worked out a confidence interval for the mean of the entire population. Now we're going to look at what's called a proportion, and we're going to look at people who smoke in this particular town. And again, let's say the town has maybe 10,000 people, 10,000 adults, let's say. And rather than asking every single adult in the town, which is going to take a long time, do you smoke, yes or no, we're just going to take a sample. So we took a sample of 1,000 of those adults, and so you know our n here is going to be 1,000, and we found that our sample proportion, we found that 443 of them smoke. So in other words, our sample proportion, which is written as p hat, p with a little hat over it, is just simply going to be 443 over 1000, which is 0.443. So 0.443 is our sample proportion. It's the proportion of our sample of adults who actually smoke. What we're going to do is find a confidence interval for P, the population proportion who actually smoke, based on this. So as in the previous video, we're going to work out a confidence interval for this particular sample here. So we are going to first of all find the margin of error around this. So the margin of error in this case, again, it's going to be plus or minus 1.96 times the standard error for the sample in this case. Now, in the previous video we were talking about means, so we use sigma over root n. In this particular case we're not talking about means, we're talking about proportions. So in this case we're going to multiply our 1.96 by the standard error of our proportion, which is our p hat times 1 minus p hat all over our sample size, square root of all of this here. So it's similar to the previous formula that we used for confidence intervals for the means. This bit here is a little bit different. Okay, so let's do that for this particular case here. So we have plus or minus 1.96 times the square root of 0.443 times 1 minus 0.443 all over our sample size. In this case was 1,000. Now when you work that out, you'll get a margin of error of 0.0307 287. Now we don't really need this many decimal places in this case. Our sample proportion was to 3 decimal places, so maybe I'll just use 3 here. So we've got to calculate our confidence interval. So we're going to have our true population proportion, again, is going to be somewhere between 0.443 minus 0.03, let's say 1 here, and 0.443 plus 0.031. Now when you work that out, you get a range of values that will be, let's see, I worked it out as 0.4122. I may have used more decimal places here previously, but you get the idea anyway. It's 0.4738 on this side, 0.4738. So 0.4122 and 0.4738. That means that we've got 41.22%, and up here we have 47.38%. So our true population proportion will be somewhere in here using a 95% confidence interval. And that means, again, if we were to do this 100 times and get 100 different samples, 100 different confidence intervals, the true proportion P of the actual population will be within these ranges 95 out of those 100 times. Okay, so that's just calculating the 95% confidence interval for proportion. That's how you would actually go about doing it. Now, just as an extension to this, what we're going to do is just look at a situation where we might have to cut the margin of error in half. So say you were asked to reduce the margin of error here in half. Now we found that the margin of error here was 0.03788 and so on. So we think maybe that's too wide and we want to cut that in half. What would our sample size actually have to be? Initially it was 1,000. If we wanted to cut our margin error in half, what kind of sample size would we actually have to take? So in this case we have to work out what n is, given that we are halving the margin of error. So first thing we've got to do is actually half the margin of error. So if you divide this margin of error here in 2, you will get, so our margin of error in this case will have to be plus or minus 0.015, 394,143. Okay, so this is half the margin of error. So what kind of a sample size would we have to take if we wanted this margin of error in particular? Well, let's work that out then. Now, we have, let's see, we have, okay, so what we're actually going to do here is just write down the equation first of all. So let's do that. Now this is our margin of error, so we're going to write down 0.015394143. I probably don't need this many decimal places, but we'll do it anyway. Now that's going to be 1.96 times the square root of 0.443 times 1 minus 0.443 all over n. We want to work out what our new sample size would be. So let's do that. Now we want to divide across by 1.96 first. So that will give us 0.007854 854,154, and that gives us the square root of 0.443, 1 minus 0.443 all over n. Okay, so in this case we have a square root here on this side, so I'm going to square both sides. If I square both sides, multiply this by itself, I'll get 0.0000 61687. So we will just end up on this side with 0.443 times 1 minus 0.443 and all of that over n. Now if I cross multiply here, or multiply across by n and then divide by this number here, I'll leave the algebra up to yourselves, we end up with n is equal to the top part here divided by this number here, and we actually end up with 4,000. Okay, so in other words, if we wanted to half the margin, original margin of error was this number here, 0.03. If we wanted to half that margin of error, we would have to take an extra 3,000 from our sample. In other words, 4,000 in total. We would have to take 4,000 adults from the sample just in order to half our margin of error.